Hello everyone, welcome back. So in this video, we are going to look at today's LeetCode daily challenge, and the name of the problem is leaf similar trees. So in this problem, it is given that a leaf value sequence of a binary tree is the sequence of its leaf node values taken from left to right order. So a leaf value sequence of a binary tree is the sequence of its leaf node values of that binary tree in from left to right order. Okay, and in the problem statement it is given that we will be given two binary trees and we need to tell whether these two binary trees are leaf similar or not. So we will return true if both the trees uh, are leaf similar and the two trees are considered to be leaf similar if their leaf value sequence is same, and we already discussed what this leaf value sequence means. For example, in this binary tree, nodes with values 6, 7, 4, 9 and 8 are the leaf nodes as they don't have any children. And if we take a sequence of these leaf nodes of this binary tree, then we will get the leaf value sequence as this array given here. So this is the problem statement. We'll be given roots of two binary trees, and we need to tell whether these two trees are leaf similar or not. So now let us look at the approach to solve this problem. So in order to solve this problem, we need to do is we need to find the leaf node sequence of both the trees first, and then we are going to compare those sequence, and if the leaf value sequence of both the trees are same, then we can return true, otherwise we will return false. Now in order to find the leaf value sequence of the given binary tree, we will perform DFS traversal one by one on each binary tree. So we will perform DFS traversal one by one on each binary tree. So let us take this example. Let us say these are the two binary trees given to us. So firstly, what we'll do is perform DFS traversal on the first binary tree. So the root of the first binary tree is node with value 5. So we will start our DFS traversal and we will check this particular node is not equals to null, and it is also not the leaf node. Hence we will first go to its left subtree, then after exploring its left subtree we will go to its right subtree. So firstly we are going to check its left subtree, then we will come to this node with value 7. We are going to check whether the particular node is leaf node or not. So we can easily see that this node is not a leaf node. Now how we will check whether a particular node is a leaf node or not? So if a particular node does not have any left child and it does not have any right child, then we can say that that particular node is the leaf node. But here node with value 7, it does have a left child, hence this node is not the leaf node, and we will go to its left subtree. Now we will come to this node with value 9, and when we will check we will find that this node does not have any left subtree and it does not have any right subtree. Hence we can say that this node is the leaf node, and that's why we are going to store the value of this node in this leaf value sequence which we will maintain. So we are going to add this in our sequence. So 9 will get added in the leaf value sequence of this binary tree. then we will move ahead. So as we are done with this node, we will go back to 7. Then we will backtrack to node 5. We have already explored the left subtree of node 5. Now we will explore the right subtree of node 5. So we will come to this node. This node is also not the leaf node, so we will first go to its left subtree, and we will come to this node 8. And we can see that this node does not have any left subtree, and it does not have any right subtree. It does not have any left child, and it also does not have any right child. So it means this node is also a leaf node, and hence we will save this value of this node in our sequence. So we will add 8 here, and we will move. Now we will go back to node 12. As we have explored its left child, we are going to now check the right subtree of node 12. So we will come to this node. Again, this node also does not have any left child and right child, which means this node is a leaf node, and hence we are going to add the value of this node in our sequence. And after that, we will go back to node 12, and we will then go back to node 5. And here we end our process. We are done with our DFS traversal. And the leaf value sequence of this binary tree that we got is 9, 8, and 4, and this will be stored in an array which we will take for this binary tree. Now the same thing we need to do for the second binary tree, which will be given to us. Now we will find the leaf value sequence of the second binary tree. So here also we will start our DFS traversal from the leaf node. This node is not the leaf node, so we will go to its left subtree. This node is also not the leaf node, so we will first go to its left child. And this node is the leaf node because it does not have any left and right child. Hence, we are going to add the value in our sequence. So 9 will get added. Then we will go back to node 1. We are done with its left child. Now we will go to its right child. Right child has node with value 8, and it is also a leaf node, so we are going to add the value in our sequence. We will add the value in our sequence. Then we will go back to node 1, as we are done with right subtree also. So we will go back to node 12. So we have explored the left subtree of node 12. Then we will explore its right subtree. We will come to this node 6. It is also not the leaf node because it does have a left child. Hence, we will go to its left subtree, and this is a leaf node, so we are going to add the value in our sequence. So here also we are done. We will backtrack. We will come back here, and we are done with our DFS traversal for the second binary tree as well. Now, after finding the leaf value sequence for both the binary trees, what we will do is that now we need to compare these two sequences, and if they are same, if the values of both the sequences are same and in the same order, then we can return true, else we will return false. So this was the simple approach to solve this problem. Now let us quickly look at the code. So this is the code to solve this problem. So here we are given the roots of two binary trees, and for each binary tree I have taken two separate arrays or lists, and one by one, firstly I will find the leaf value sequence for the first binary tree, and then I will find the leaf value sequence for the second binary tree, and then here what we are doing is we are simply comparing the two sequences of the two binary trees, and if at any particular point the two sequences differ, then at that moment we are simply returning false, and if all the values are same and in the same order, we are returning true. Now in order to find the leaf value sequence, I have written a DFS function, and one by one we are sending the roots of each binary tree in this DFS function. So in the DFS, this is a simple DFS uh, process where we are first checking if the root is none, we will return simply. Else, uh, the second base condition is that we are checking if that node is a leaf node. So the condition for a node to be a leaf node is that it does not have any left child, and it also does not have any right child. Then we can say that that node is a leaf node, and then we will add the value of that node in our sequence and we will return. Otherwise, we will first explore the left subtree of the current node, and then we will explore the right subtree of the current node. So this is the simple DFS solution to solve this problem. And if I submit this code, so as you can see, uh, this uh, this solution got accepted. So this was it for this video, and thank you. Have a nice day.